Magnificent monsters of Maker Electronics, it's Prof. G, and in this lesson of CircuitPython School, we're going to learn how to play MP3 files on the boards that can. And while doing so, we'll get a little bit of inspiration from everybody's favorite wrinkly green Jedi.
Code or code not. There is no try.
Let's learn big! So why don't you plug in your properly configured CircuitPy board, and if you're new here, you might want to follow along with the earlier lessons in the playlist to see how we got to this point. Now, I'm going to initially use the CircuitPlayground Bluefruit, but I'll modify the same code so that you can see it running on a Raspberry Pi Pico. When I use the Pico, my audio wire is going to be connected to GP15 with the other end clipped to the tip of a speaker audio jack, and the ground wire is going to be clipped to the jack's base. Now, if you're not using a CPB or a Raspberry Pi Pico, know that only some boards can play MP3 files. Now, to find out if your board can run MP3 audio, you can enter the REPL and use the help modules command that we learned about in an earlier lesson. If you see audio MP3, like I'm showing here for the output for the CPB and the Pico, you're golden for MP3 play. If you can't find audio MP3 in your output, you're out of luck. Sadly, for those of you that only have a CircuitPlayground Express board, no soup for you. And also remember, there are literally hundreds of other boards that support CircuitPython. You can use help modules to get the scoop on those boards as well. Now, it's usually boards with weaker or slower microprocessors that can't run MP3 audio, because playing MP3 audio is more computationally intense. MP3 files are compressed. Now, the advantage is that they're smaller. For example, if we compare the alarm sounds that we downloaded in an earlier lesson, we can see that the WAV file is about 6 times larger than the MP3 file. This also means that the code to decompress a file requires a more powerful board, and the CircuitPlayground Express simply isn't as powerful as the other boards. Now, another difference is that MP3 files are considered to be lossy, meaning that some audio fidelity is lost in the compression process, whereas WAV files are lossless. But frankly, most Maker projects aren't used in a context where folks would be able to tell the difference, so using MP3s instead of WAV files should give you more room for more files or larger files in your projects. Still, do know that the space on most microcontrollers is very small. In a future lesson, we'll show you how you can wire up a micro SD card to a Raspberry Pi Pico to give you gigabytes more storage. Now, to get us moving quickly, I've got some MP3 files for us to work with. You can download these at bit.ly/CircuitPython-school-files, all lowercase. Find the folder named Sounds, double-click to open it up, and I have 3 MP3 files in here. So I'm going to Command-click to highlight all 3 of these, then right-click to download, and you can also see the difference in file size here. I have WAV versions of these same files, and you can see the MP3 versions are less than 1/5 the size of the WAVs. Now, your files are probably being saved to your downloads folder. Mine are going to save to the desktop. Google Drive puts the folder in an odd name, but I'm just going to rename the folder to just Sounds, all lowercase, and I'll drag that into my CircuitPy volume. And you can see I've got other sound folders in here, alarm and drum sounds from earlier projects. You can actually delete these folders if you're running out of space. We're only working with the sounds folder in this lesson. Now, you can absolutely use your own MP3 files if you'd like, but remember, space is limited, so don't expect to copy over very large files or lots of files. Adafruit says that files that are 32 to 128 kilobits with sample rates from 16 to 44.1 kilohertz work best. That might not mean anything to you, but in an earlier lesson, I pointed out that there's free software called Audacity available for Macs and PCs. You can download this at audacityteam.org, and this slide shows you where you can find those settings. Now let's check out the code we need to get things working. Now, this first slide looks familiar. It's got the same code that we used when playing WAV files, except for the from audio MP3 import MP3 decoder line here, which is specific to playing MP3 files. Everything else is needed to set up the speaker, so we import board and digital I/O as well. In our WAV lesson, I pointed out that this block of 7 lines of code allows our code to be more portable. So if you don't know which type of audio you support, audio I/O or audio PWM I/O, this block of code can figure it out for you. But if you know you're only going to be running your code on a Pico or a CircuitPlayground Bluefruit, you can actually just include this line that I'm pointing to with a red arrow. These next 3 lines of code are specific to the CircuitPlayground boards. If you want to use the internal speaker on these boards, you need to include these lines, but do not include them on the Pico or other boards. Then down here, we create the audio out object. We always call this audio, and note that board.speaker is what we use on the CircuitPlayground Bluefruit or CPB. For the Pico, you would instead say board.GP, followed by whatever pin number you're using for your audio out. And also note that the path is the name of the folder containing our MP3 files. In this example, that's just sounds, but make sure that you've got the slash at the end because that separates the folder from the file name we'll add later. Now here's the code that's specific to playing MP3 files. So this block of 3 lines is used to create an MP3 decoder. That's a software object that actually decodes the file into something that can be played. So we should create the object first because this is computationally intensive. It takes up a reasonable amount of memory when you create the object. So if we create this MP3 decoder once and then reuse it whenever we need to use an MP3 decoder, it's more efficient. But when you set up a decoder, you need to supply a valid MP3 file name that's on the board. So this is what we're going to do. We're going to set the file name variable to a valid file name. Be sure to change this if you use this code in future projects with different file names. Then we read in our MP3 file using the open statement. We pass in the path, our folder, and the file name. RB means we read the binary values, the raw data from the file. Then we use this MP3 file to create the MP3 decoder object, and we call it decoder. Next, we create a function that we can repeatedly call whenever we want to play an MP3 file. So we set the decoder's file property by reading the file name using the open command, just as we did above. But remember, because we can pass in a different file name, we can read in a different file. Then by passing the decoder into the audio object's play function, we play the sound. And we don't do anything while the audio is playing, but as we showed in earlier lessons, we could call additional functions from inside this while loop if we wanted to perform some other tasks while the sound was playing. Just replace the pass statement with a function call. And then to play a file, we just call play_mp3, passing in the string of a valid file name. So why don't we head over to PyCharm and code this up, playing the 3 files that are in our sounds folder. And I no longer need the sounds folder on my desktop, so I'm going to throw that away. And I'm going to launch PyCharm. And I'm going to delete all the code from my previous build, and I'll add a comment up top that says mp3-sound-play.py, and we'll import board, digital IO, and also from audio mp3, import MP3 decoder, and that's with capital MP3 and D for decoder. Next, we need to read in a class so that we can create an audio out object. Now I'm going to add all 7 lines here to be able to use this code on any board that does audio out. So I'm going to say try : from audio IO import audio out, capital A, capital O, except import error, capital I, capital E, : then try : from audio PWM IO import PWM audio out with a capitalization as shown as audio out. Now again, if you know you're only going to run this code on a CircuitPlayground Bluefruit or a Raspberry Pi Pico type board, then you can just use this single line we just entered. You don't need all 7 of them, but all 7 lines makes our code most portable, so that's why I'm entering it all in. Then the next line is except import error : then indented print this board does not support audio out. So again, some boards don't support any audio out, some use audio IO, some use audio PWM IO. If you're using an unfamiliar board, make sure that you check the output in TO to see if you get this error. Then we've got 3 lines to set up the speaker for the CircuitPlayground boards, but not for the Pico, so don't use these 3 lines if you're using a Pico or a non-CircuitPlayground board. I'll say speaker equals digital IO dot digital in out with this capitalization, and then I'm going to pass in board dot speaker underscore enable. Make sure that you get the underscore enable in there because there are a couple of speaker options. Then on the next line, speaker dot direction, and set this equal to digital IO dot capital D direction dot output in all caps. And then we set the speakers dot value property equal to capital T true. Next, we're going to use the speaker's location to create an audio out object named audio. So we'll say audio equals audio out, capital A, capital O, passing in for the CPB, it's board dot and an all caps speaker, not speaker underscore enable this time. But if you're using a Raspberry Pi Pico, for example, you want to say board.gp, whatever the number is for the pin that you're clipping your audio out to. In the diagram I showed, it would be board.gp15, and GP are both caps. Then we set up the path, which is the name of the folder with a slash after it. Path equals, and in between double quotes, sounds slash, make sure that you've got that sounds folder on your CircuitPy board. Then we want to set up an MP3 decoder object. We do this first and only once so we don't have to recreate it because that's computationally intensive. And to do this, we need to supply a valid file name that we have on our CircuitPy volume. So I'm going to say file name equals, and in between double quotes, I'm going to say encouragement1.mp3. And if you're worried about getting the spelling right, you can just pull up your CircuitPy volume, find the file you want, press return on it, Command A to highlight all of the characters, Command C to copy it, and then head back in and paste it between the double quotes. I do stuff like that all the time because I'm a terrible speller and I have terrible vision, a terrible combination. Then we're going to read in the data from that file into a variable called mp3_file, setting this equal to open and between parentheses path plus file name, comma, and in between double quotes RB to read in the binary from the file. So that raw data is in the mp3_file variable. Next, we're going to set up our decoder. We're going to call it decoder, lowercase d, and we're going to set this equal to an mp3 decoder. This is a class that we imported, and in between parentheses, we're going to send this to the mp3 decoder factory to create an object by passing in mp3_file, the variable we created above. So that sets up our decoder friend, and the only thing that you would need to change here if you were going to reuse this code is the file that you put into the file name if you have different files on your CircuitPy volume. Also remember to change your path name if your files are in a different folder name. Then we'll create a reusable MP3 playing function with def space play_mp3, and between parentheses we're going to pass in a file name, colon at the end, and indented below this we'll say decoder.file, reading into this property, equals, and it's the same open statement we typed above. Open, and between parentheses, path plus file name, comma, and in between double quotes, RB. So we read the data in off of the file for whatever file name we passed in here. It's in the file property of the decoder, and now we're going to use that decoder in the next line. Audio.play, passing in between parentheses, decoder. This is going to start playing that MP3 file decoded into something we can play. And then below this we'll say while audio.playing, colon, and indented below this we'll say pass. Now you could replace this pass line with the name of any function that you wanted to run concurrently while the sound was playing. But friends, down below, let's call this function 3 times. Make sure that you've outdented all the way even with the definition of the function. And we'll say play_mp3, passing in the string encouragement1.mp3, then play_mp3 encouragement2.mp3, and how about play_mp3 in between quotes nice-work.mp3. Open up the terminal, get into TO, save the file, and there's really nothing to watch, but you can hear the audio captured by my iPhone.
Code or code not. There is no try. A code monster you have become. Skilled you are.
Nice work.
And listen to that. All 3 of those files play. Nice work. You've got lots of reusable code in here that you can use. So let's make sure that we save this to our CircuitPython school folder as mp3-sound-play.py. Close that outermost tab. Now, as promised, let's get the code running on a Raspberry Pi Pico. So you can see I got my Pico plugged in here, and GP15 is plugged into the tip of the audio jack, and any ground can go to the sleeve of the audio jack. Now let's modify our code. First, since I'm using a new board, I'm going to get into the terminal and enter CircuitPython_setboard space Raspberry_Pi_Pico_W. That'll just make sure that PyCharm knows everything that's part of the board library for this board. Then I don't really need to make that many changes. I'm going to highlight these 3 lines that are specific to the CircuitPlayground boards. With the 3 lines highlighted, I'm going to command / that comments them out. And where I create my audio out object named audio, I'm going to pass in board.gp15, capital G, capital P. That's, again, the pin number that my audio out is attached to on my Raspberry Pi Pico board. Nothing else needs to change. I'm using the same folder name with the same file names inside of it. So I'll open the terminal again, get into TO, save my work. And again, it doesn't seem to be running, so I'm just going to put another space in here and save again, and now it works.
Or code not. There is no try. A code monster you have become. Skilled you are.
Nice work.
You are a code monster. This is nice work. Cross-platform code, so big learning in this lesson, which was really all about making sure that you could use MP3 files. In CircuitPython, we learned only some boards can play MP3 files. We learned how we can figure out if the board does play MP3 files. We learned why MP3 files are sometimes better than WAV files, mostly with smaller file sizes and with an audio quality that's still pretty good for most maker projects. And we saw how we could modify our code to work on a CircuitPlayground Bluefruit or Raspberry Pi Pico boards. So I hope you're feeling good about those skills, maker. Get out there and make something awesome, but be sure to come back because there's more big learning to come.